Hello and welcome to my video for Demo 8. We'll be briefly going over the 4 learning targets for this demo. We'll be learning how to read state diagrams representing finite state machines, using next state tables to summarize FSM operations, implementing FSMs with logic circuits, and then designing an FSM counter in our case, with an asynchronous input. And yeah, this is sort of in line with what we were given in the quiz. Our goal is to design a counter with mode control that cycles from 0, 1, and 3, skipping 2 altogether. Mode switch decides the turn pattern, meaning on mode 1, it'll count up from 0 to 1 to 3. On mode 2, when it is 0, it'll count down from 3 to 1 to 0. And we must use an asynchronous clear switch and D flip-flops. So in this in the state diagram, we can see clockwise what is represented, but for how it represents the 2 modes. You can see in mode 1 it'll go from A, B to C, from 0 to 1 to 3. Contrarily, on mode 0 it'll go from A to C to B, and cycle that way. And let's take a look at our next state tables. So right here we have our state table. We have our current state, the name and the mode, and its associated next state. And using these, we ended up sussing out what we needed to do with our 2 D flip-flops in order to get the desired sequences. And from this table, we then designed these 2 Carnot maps. They help point out what Boolean equations we need to use to build the circuits in Logicsim. Let's go check those out. So right here we have our finished circuit. Clear that. As you can see, there's the asynchronous control that clears the outputs regardless of clock or input activity. We have our Boolean equations put into circuitry in order to configure our D flip-flops. And if we can just go over the states, the modes. That is in mode 1 right now, and it'll be counting from 0 to 1 to 3. Let's see, 0, 1, 3, and when it's 0, it'll be doing the opposite, 3, 1, 0. And yeah, that is a summary of all 4 learning targets for Demo 8. Thanks for watching.